All right, so in Unit 1, polynomials, we started by adding and subtracting polynomials. We've been doing this ever since we started with algebra, and really it's just a matter of combining like terms. So in the first term, I have a negative 3v to the fourth, which I am going to combine with 4v to the fourth, and I'm subtracting them. So that gives me negative 7v to the fourth. And then I'm going to look in the first term, there's no v squareds, but there's a v squared right here. So I'm going to take away 7v squared. And then in the first term, we've got 4v minus in the second term 1v. So that's just plus 3v. And then in the first term, we have a 7 minus 7 in the second term. So those go away. So there's our answer. All right, go ahead and take a second to do number 2. Pause, and I'll put up the answer. For the second thing, we have multiplied our polynomials, and so we had a lot of ways to organize that. I predominantly used that area method, so I made a box, and on one side of the box I wrote x minus 2, and on the other side of the box I wrote 1, 3x, and negative x squared. All right, and so when I multiply these, 1 times x is x, 3x times x is 3x squared. Negative x times x is negative x cubed. Negative 2 times 1 is negative 2. Negative 2 times 3x is negative 6x. And negative 2 times negative x squared is negative 2x. I'm sorry, positive 2. Negative times a negative. X squared. So if we add up everything that we have 1 negative x cubed. We have 2x squared, so 3 plus 2 is 5x squared. We have x and negative 6x, which makes negative 5x, and then we have a negative 2. Go ahead and pause, and I'll write up the answer to the next one. All right, on to the next ones. All right, then we talked about how to find the quotient, which means how to divide. And we had two ways. We had long division and we had synthetic division. I'm not going to require you to use long division or synthetic division. It's up to you. I'm going to do the examples with synthetic division. Now, synthetic division was definitely easier, but we have to make sure that we remember that when we use synthetic division, we have our terms in order from highest power to lowest power, and that we also have a number to represent each term. So I'm going to go ahead and rewrite this as 3x cubed plus 4x squared plus 0x's plus 10. And we want to divide that by x minus 2. The reason I'm putting in that 0x is because, like I said, every term has to be represented. So here's 3, 4, 0, and 10. And in the box, we put the opposite of the number we're dividing by. So the opposite of negative 2 is positive 2. And then we go ahead and we bring down the first term, always bring down the first term to be a 3. Multiply 3 times our number in the box, which is 2. 3 times 2 is 6. I write it here, and then we add down. 4 plus 6 is 10. And we multiply it by the number in the box, which is 20. Add down 20. 20 times 2 is 40. And add down, and we get 50. The last number is a remainder, so I always follow it up with writing that r, just to remind me of that. What we have left is our answer, 3x squared plus 10x plus 20. The power is decreased by 1, and we have 50 divided by x minus 2 as our remainder. Now it's important that we have this remainder to know that this is not a factor. X minus 2 is not a factor because there was a remainder left over when we divided. To do the next one, I want to remind everyone that we can only use synthetic division if the number that we're dividing by starts with an x. And since this starts with a 2, we have to get rid of that 2. So that means we have to divide every single term in the entire problem by 2 to get rid of it. And in this case, a lot of those terms are divisible by 2, but sometimes it can result in fractions. So if I went ahead to set this one up, I'll set it up for you. It would be 2 from the 2x squared, negative 6 from the negative 12, and 9 halves. There's no need to write any zeros because every term is represented. The number in the box is going to be the opposite of this number, so negative 1/2. And then go ahead and if you go ahead and pause the video and then check your answer in a second. All right, on to the next one. Then we use Pascal's triangle to rapidly expand binomials that were raised to a power. If you want to do this a long way, it would be y plus 3 times y plus 3 times y plus 3 times y plus 3, which is an awful lot of FOIL. So Pascal's triangle helps us do this more rapidly. You need to be able to come up with as many rows of Pascal's triangle as I asked for. Honestly, the beginning is really easy. It just starts with 1s, so 1 at the top, 1 on the outside. And now we can add ahead 2 and 1 plus 1 makes 2, 1. And 1 plus 2 is 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and 1, 6, 15, 20, 15, 6, and 1. All right, we would use this because we need to have whatever row matches this power. So because we're looking at the fourth power, we're going to go ahead and grab the row that has a 4 in it. These numbers are included in our binomial expansion. So 1, 4, 6, 4, 1. I went ahead and organized it in a table because that's how I usually do things. It was easier to me. We start by taking the y, and the y gets the power of 4 and then decreases until it disappears. And you're welcome to write y to the 0. I'm just going to go ahead and cancel it out since there are no y's. Y to the 0 is just 1. And then we go ahead and take 3, and we start with none of them and add them up. 3, 1, 3 squared, 3 cubed, 3 to the 4th. And that will always work out. And then we go ahead and multiply each column. So 1 times y to the 4th is 1y to the 4th. Plus 4 times 3, which is 12, y cubed. Plus 6 times 3 squared. 3 squared is 9. 6 times 9 is 54, y squared. Plus 4 times y cubed. Y cubed is 27. 4 times 27 is 108, y. And the last one is 1 times 3 to the 4th, which is 81. All right, factoring. We spent a lot of time factoring in Algebra 2, so hopefully you'll be able to do this by heart. The first types of things that we factored were just regular quadratics, and now once we've done polynomials, we learned 2 other techniques. We learned to factor by grouping, and we also learned sum and differences of cubes. So the first 2 are factoring by grouping, and we know this because there are 4 terms. So as soon as I see 4 terms, I know that I'm going to have to group them. When I group these 2, I look for their greatest common factor, which happens to be x squared. When I take out the x squared, I'm left with x minus 2. When I group the next pair, the negative 9 and the 18, I see that they both have a 9 in them. So I might just be tempted to take out 9, but I want the beginning of my parentheses to be a positive x. So I'm actually going to take out the negative 9, which will leave me with x. And now because I took out a negative 9, the 18 becomes negative 2. This is important because by grouping, these 2 need to match, always. So you can kind of help guide that. We are taking out the second pair. So one of those, x minus 2, becomes one factor. And the other factor is what's remaining from the first term. What we took out was the x squared. For the second term, we took out the 9. All right, you're only done factoring when there are nothing left that can be factored. And you should see, when you see x squared minus 9, you should say it's a quadratic. They're both perfect squares, and they're subtracting. So that's actually a difference of squares. That means this term can turn into x minus 3, x plus 3. This won't always happen, but it does happen in this case. If you want to go ahead and pause the video and then do that next one, I'll put up the answer. Okay, there you go. There's the answer. And don't be tempted from this second one to go ahead and factor x squared plus 4 any further. It's a sum of squares, and there's no special rule for a sum of squares, so we can't factor that. All right, for the next one, there's only two terms, and one of them is cubed, and actually it turns out they're both perfect cubes. They fall into our difference because they're subtracting cubes, a cubed minus b cubed. This is a formula that you needed to know. It turns into a minus b times a squared plus ab plus b squared. And I said that if you remember a's and b's where they are, then the signs are the same as SOAP. This first sign is the same as the one in the problem. This one is the opposite of the one in the problem, and this one is always positive in the end. So now all we have to determine is what a and b are. A is 2y, because if I cube 2, I get 8, and if I cube y, I get y cubed. B is 3, because if I cube 3, I get 27. So now, if I go ahead and plug them in, 2y minus 3 times 2y squared, I'm going to put that in parentheses because I need to square it, plus 2y times 3 plus 3 squared. Now if I go ahead and clean that up, I have 2y minus 3. If I square 2y, I have to square the 2 and the y, which is 4y squared. I have to multiply 2y times 3 and I get 6y, and 3 squared is just 9. So that is my factor. For the next term, I'm going to leave you to finish it up, but basically these are not cubes. There are only two terms. So the first way we factored anything was we found a GCF. In this case, 4x is a GCF. I'm sorry, 5x is a GCF. So if I go ahead and take out the GCF of 5x, I'm left with x cubed plus 8. And this is x cubed and 8 are both perfect cubes, where a would be x and b would be 2. The signs are going to go ahead with SOAP, so they're going to be different than those signs that you have in the factoring right there. But I'll go ahead and I will write the answer for you. And there you go, there's the answer. Like I said, the signs are the same as the one that's in the problem, the opposite of the one that's in the problem, and this last one is always positive. All right, solving by factoring. We had a huge test on solving by factoring, and it really just incorporated the examples that you had, the techniques that we learned in quadratics and the new types of factoring. So we're always looking for a greatest common factor if we have one. In this case, we have x cubed goes into all three of these. And so if I took out x cubed, then I would be left with times, oh, not 5, oops, 3 x, oh, actually, I'm sorry, the greatest common factor actually includes more than just x cubed. It includes the 3 as well. So if I take out 3x cubed, I'm left with x squared plus 6x plus 9 equals 0. And then inside here is a quadratic, and it's a trinomial, and so the two numbers that multiply 9 and add up 6 are 3 and 3. So this part can actually be factored into x plus 3 times x plus 3. We can't forget about our 3x cubed out front. And then if we think about it, well, it's already factored, so we're allowed to go ahead and set everything equal to 0. 3x cubed equals 0, x plus 3 equals 0, and another x plus 3 equals 0. This gives us actually 5 answers. X cubed being 0 gives us 3 zeros. And these guys give us negative 3's. So these are our 5 answers. It looks like it has multiplicity, right? So therefore, the 3 zeros would represent a bend, and the 2 negative 3's would represent a bounce. If you go ahead and try the second problem, it's going to be factoring by grouping, but don't forget to bring the negative 48 over to the other side, and I'll go ahead and write the answer for that one. And there's the answer for the next one. So the next type of thing we did with roots was we actually looked at graphs. And so from the graphs, we were able to find the roots because all of the roots in quadratics and polynomials are where the graphs cross the x-axis. So in this case, this first graph crosses the x-axis right here at 0, and it crosses the x-axis over here at -3. Now, normally when we cross the x-axis, we just go straight through the x-axis. But actually at -3 and 0 here, we do different things. So at -3, we have what's called a bounce, because the graph comes up, hits the x-axis, and bounces back down. A bounce represents even multiplicity, meaning that -3 occurs as an answer an even number of times, either 2 or 4 or so on. In this case, it will actually be 2 times. And 0 represents a bend because the graph is not just going through, it's bending. Bends represented odd multiplicity. And so this means that 0 occurs either 3, 5, 7 times. It can't occur once because that would just represent going through once. If you go on and do the next one, it goes through the x-axis over here at -1. Now at -1, it just goes through. It doesn't do anything fancy, so therefore -1 is just an answer once. It comes back through the x-axis at 1. Once again, it just goes through, nothing fancy. Over here at 3, it bounces, which represents an even multiplicity. And that will actually happen 2 times. All right, on to the next one. Okay, so we also worked with you writing an equation of a polynomial if I just gave you the roots. This kind of going full circle, going backwards. So what we have learned the whole time is that when we have the roots are actually the opposite of those factors that we have been seeing. So when I know that a root is 3, that means x minus 3 was a factor. And when I see that -1 is a root, that means x plus 1 is a factor. And when I see that 5, that means I know x minus 5 is a factor. So if I know these factors, then I can go ahead and multiply them out, and then I'll come up with a polynomial that has those roots. So if I go ahead and use FOIL here, then I'm going to get x squared, and then I'm going to get plus x minus 3x and minus 3 when I multiply out those first two. And if I go ahead and combine like terms there, which I'm going to in just a moment, that would give me x squared plus 2, sorry, minus 2x. Hold on a second. I'm going to get x squared minus 2x, because if I combine those middle terms, that would be minus 2x. Oops. And minus 3, and then obviously times x minus 5. And then what I would need to do is I would need to refoil out, or use that box to multiply this trinomial times this binomial. And if I did that, if I multiply x, I'm going to go ahead and FOIL it because it's a little easier on the computer here. I'm going to get x cubed, and then I'm going to get minus 5x squared, and then I'm going to get minus 2x squared, and then I'm going to get plus 10x. Oh, 10x, and then I'm going to have minus 3x, and then I'm going to have plus 15. And if I go ahead and combine like terms here, sorry for taking a while to do this. If I go ahead and combine the like terms here, then I will get x cubed minus, it looks like 7x if I combine those two, and then plus 10 and minus 3, which would actually become plus 7x, plus 15. And this is a polynomial that has these 3 roots, 3, -1, and 5. When you go ahead and do the next one, root 2 and I, Don't forget that when you write out your roots here, you would have, I'm going to kind of have to write it on the screen here. One of them is going to be x plus root 2. But because of the irrational root theorem, x minus root 2 is also a root. It kind of hides a root. So it looks like there's only 2, but there's actually 4 because of the imaginary root theorem. You would have x plus I from the one that you see, and you would also have x minus I, which is a hidden root. So when we multiply out the 4 of these, we get our polynomial, and we'll check our answer for that one in class. All right, finally, we had the word problem, which you guys seem to do really well with, and this required us to use a calculator, so I'm going to be using a calculator here, which is where I'm getting a lot of these numbers from. And so the first thing we wanted to do was we wanted to classify it by degree and number of terms. That was really hard for a lot of people on the test. Degree, it's a third degree, which makes it cubic by degree. I should probably just type this, but I don't know, cubic. And it has 4 terms, which makes it, you could either call it a polynomial or a quadrinomial. So I'm going to go ahead with a polynomial. Anything over 3, we generally start to call a polynomial. But if you wanted to go ahead and call it a quadrinomial, that would be correct as well. All right, so then we went ahead and we put this into our calculator in y1. So I have 0.2 x squared minus 2x, oh, so I apologize, 0.2 x cubed minus 2x squared plus 4x plus 5. And then to fill in this table, I literally went to table, second table. Make sure that your table set is set to autofill. So second table, make sure it's set to auto, and I want it to start at 0. This calculator needs a little help. So at 0, I get the answer 5. Let's see if you guys get the same answers as me. So at 0, I'm getting the answer 5. Okay, I just want to move that. And okay, this is not going to be nice to me today. All right, so at 0, I get the answer of 5, and at 1, I get 7.2, 7.2, and at 2, I get 6.6, and at 3, I have 4.4, and at 5, I have 0, oh sorry, 4, I have 1.8, at 5, I have 0, at 6, I have 0.2, at 7, I have 3.6, and at 8, I have 11.4. Okay, explain why the height of the bird at t equals 0 seconds. It's 5, and why would this make sense? Well, hopefully it makes sense because it's in a tree or something. It's off the ground, so that would hopefully make sense. Make sure also when you plot these that you actually go ahead and put the dots on the graph. You just got all those points, and now we actually want you to put those points, 1 at 7.2 on the graph pretty accurately, 2 at 6.6. I don't expect to be perfect, but I do expect them to look somewhat like it. 4.4 for 3, 4, 1.8. 5 is at 0, 6 is at 0.2. So it actually goes below ground there. 7, 3.6. 8 is at 11.4. 11.4, and that was all we needed. So find the height at 2, 5, and 8 seconds. Well, we pretty much have done that. At 2 seconds, it's 6.6. At 5 seconds, it's at 0. And at 8, it's 11.4. What does that mean? Well, at 6.6, it's in the air, and 0, it's on the ground, and 11.4, it looks like it's taking off. The height at 60, so there's a couple of different ways to do it. I'm going to go ahead and get from my table, I'm going to ask it to show me 60. And at 60, it actually tells me it's 36,245, 36,245. And that does not make sense at all because a bird cannot fly higher than Everest, that I believe. What's the minimum height of the bird? So the minimum height, if I go ahead and look at my graph, the minimum height, it actually looks like it goes below. So I'm going to use second calc minimum, and I'm gonna look from 4 to 7 and see what happens. From 4 for my left bound and 7 for my right bound. And it looks like the minimum is actually negative 0.22. So at 5.44, it goes at negative 0.22. So does it make sense? Probably not. It would mean the bird would go underground. I guess if it was flying next to the sea, it is possible. But since it says it's in a meadow, no, because it would be underground, and that really wouldn't make any sense. What's the maximum height of the bird from 0 to 8 seconds? Well, from 0 to 8 seconds, it is highest at 11.4. 11.4, and this occurs at 8 seconds. Clearly describe the end behavior of this function and give a reason for this behavior. So the end behavior is that as x approaches negative infinity, the graph, the function approaches negative infinity. And that's because the graph will continue to go down. But as x approaches positive infinity, the graph will actually continue to go up. So it'll go towards positive infinity. All right, and that was polynomials.